We have 18 people. Um, so we have today's Wednesday, right? So we have today's class, and then next week we have two lectures. So total we have three. And today I want to finish the database um, portion of it, and hopefully you will like it. Maybe you want to use this to implement the project I gave to you for the final exam. Okay. It's actually a very good opportunity to use this very, very important tool. Okay, so it is a kind of a natural extension of data structures we learn. Okay, so it's used widely in almost every single every single application we see. So I think it's a very good idea to understand it and get a chance to practice it a little bit so you can put on the resume because that's always a big plus to know database. I often hear people ask me for candidates to apply for the jobs, and then almost every time they need people to do database. It's just because it's so common. Very few people actually use data structures, what we did, to implement applications unless it's very simple. If you have a lot of data, then usually we'll use database. So I think it's a good opportunity to try it out and get some idea about it. Okay. um, well, I think I would like to announce something. I think it's good news. One of our students in this class, if you don't mind, applied to NYU because NYU is his dream school. So he applied to NYU and then got accepted for the spring semesters. So I would have to say, I want to say congratulations, and this is great news. I remember I wrote his letter of recommendation, and then I was very proud of him. Um, and he was able to get in. Not only he was able to get in, but also his courses got all accepted. All the computer science courses got accepted, and he even mentioned that our level is actually ahead of a lot of their students. They teach the kind of stuff in the third year or fourth year, so I'm very happy to hear that. I want again to assure you that our quality is good and you shouldn't feel bad about it. I think it is good decision to come to Suffolk. I cannot say this about other majors, but I know computer science, if you do the work, you should learn quite a bit. So after this course, if you are able to keep up with the work, I think you'll be able to create anything, almost anything, especially when we finish the database. And the next week, we're going to talk about um, JSON, how to get the data from different places on the internet. So, um, so those are things are the major components of applications, in modern days. So, congratulations, and it's a good thing for him, of course, but it's also a good thing for our program. I think it's good news for you guys. That means if you want to apply to anywhere, um, be confident that you will look upon favorably. I think. Okay, I never heard of anything say anything bad about our program in any school, so nobody complained ever. So I think that's good. All right, so I would like to start with the SQLite Manager, which is an extension on the either Chrome or on Firefox, right? We talked about this last time, And so I showed you how to install the extension, right? So hopefully you have it on your computer. And on my computer, I'm going to share my screen with you so you can see what my screen looks like, right? So here you see this icon, that's called a SQLite Manager. No, you can't see it, of course. So I need to present it first. Hold on 1 second. Okay. So now, can you see my screen? Yes? Okay, so here is the manager, and then we get to the screen. There's a SQLite Manager, okay? Um, so it turns out that SQLite Manager has two versions. This is the newer version that I don't even know much about it. It just came out recently, and they are implementing it. They're not complete this yet. So, so I was very confused to look at this, but fortunately, it still has the old version. Okay, so if you right click on the icon on the um, uh, the secret manager icon, you will see there is a old interface, right? Can you see it? It's small, it's an old interface. So pick that one, and then you will then you open it. Then you have something like this. So this is much better. Okay. All right, so we're going to divide today's lecture into two parts. One part is to learn SQLite, okay, which is a variant of the SQL language. So if we know SQLite, then chances are you're going to know everything else about the SQL, because this is a slightly different from the other SQL variants. Every variant is slightly different, so but most part 95% I would say they're the same. Yeah, I think it's a noisy. There's a construction company pouring some concrete near my house. Does it bother you? Can you hear me still? Yeah, I can still hear me. Okay.
Yeah, you're good.
Okay, good. So so this is the old interface I'm familiar with. And there are many such managers, but this is the one came with the Chrome, so I thought it's easy to use. It's a good place to learn SQL. Okay, um, so so this is the place we can practice, right, and learn the concepts. And then there's a website I want you to know it. That's called SQLitetutorial.net. Okay, SQLitetutorial.net. So if I just go to the site, okay, and that gives you this SQLite tutorial. Okay, this has everything. It has everything you need to know about the SQLite, and 95% of everything about the SQL in general. And especially if you want to apply this to our Java project. And here there is a section on SQLite. You see SQLite Java. Okay, that has everything on how to combine both Java and the SQLite to do database. Okay, to store data, retrieve data, update data. So these are the two things you need. One thing is just SQLite Java that has to do with the Java, and then or in general just a SQLite tutorial, and it has all the commands. But most we are not going to need. We just need a few. Okay, so I'm going to go over those few with you, and then we need a place to practice. And to practice, we're going to use the SQLite Manager. Okay, this is where we're going to practice those commands. Okay. All right, so the first thing we're going to do is we will try to go to manage. You see the manage. That's where you're going to create a new database. Okay, that's going to create a new database. So you click on create a new database. Okay, and then you will have something like this. You see this? So the comments is statement is already provided for you. You just have to make some small changes. For example, I want to make this database called user DB. So user database. So whenever you see DB, you know that's what we use to, by convention, use to represent this is a database file. Okay, so the extension of the database file for SQLite is usually .SQLite, but it could be anything. It could be .db, lowercase db. Okay, but most people will just say the name of the database, then dot, then followed by SQLite. That's just the common. Okay, it doesn't have to be this, can be anything, but this is just a convention. Okay, the statement start with db underscore new. Okay, so now you hit enter. When you hit enter, it will execute the statement. That means we're going to create a database. All right, so hit enter. And now you see a new SQLite database is created. So now there's a database. The database is empty right now. Okay, it's empty. Now, database is like a file, especially in this case, because the SQLite is a file-based. Unlike Oracle database, Microsoft SQL Server, MySQL, those are actually a program of its own, right? It does a lot of things. It's a server, okay? But SQLite is much simpler. So it's just a file. It doesn't need other program, doesn't need C++ or Java, nothing. It's just a file, okay? So that's why it's easy to learn, at least, and plus it's more than sufficient for most of the applications we need. All right, so database is created. This is a file. There's nothing in it, right? Now, a database is made of tables. You have to remember that. Okay, so a database is made of tables, and the tables are like Excel spreadsheets. Okay, each table is made of columns and rows, columns and rows. Okay, now if I open an Excel um, uh, program, is right. So that's really a table. Okay. For example, each column you could say ID. Okay, that's the column name. Then you can say username. Okay. Then you can say password. So now that's a table. Okay. So this table has three columns. First column is ID, like a student ID, user ID, right? Username and password. Okay, so now you can map this to an object or to a class. So the class will have three instance fields. Okay, one would be the ID, one would be the username, one would be the password, right? So the user ID could be integer, could be a string. Remember we've been doing this, right? And then also username usually is a string, password is a string, correct? So you can see already a table can be mapped to a class. So we can write a Java class to match this table. Okay, now if we have the values in the table, okay, so like ID is 1, okay, and username is say John, and the password is Doe, for example, if that's the case, right? So what is this then? This is an object, if you think about it, right? Because that's actually data stored in an object. So one object with the ID of 1, username is John, password is Doe, correct? Okay, so if you have another object, fine. Maybe ID is 2, this is Jane, and then this is Dom. So you can see this is a perfect match with Java class. Okay, so in fact, for every Java class, you can create a table. So that's why there is a match, especially when you use, I mentioned something called a JPN, Java JPA, Java Persistence API. Remember that? Okay, so that is really doing the map. Okay, so on the Java side, we just write the Java classes. The JPA, Java Persistence API, will create a table for you to match the class behind the scene. So you don't need to worry about the table on the Java side because the JPA does it for you. So that made it possible. Okay, of course, when we have a Java class, we have getters and setters, right? Right, we have constructors, right? So correspondingly, a SQL table, a SQL database table, also has comparable statements for insert things, to create things, to add things, to retrieve things, to like getters and setters, and update things and delete things, so on and so forth. Okay, so there's always a match between Java and SQL or SQL database. Okay, so except that Java uses Java syntax, SQL uses SQL syntax. You got it? So it's totally different language. So that's why we need to learn the SQL language at least a little bit today. So this way we know how to put the SQL language into our Java to manipulate the database. You understand? Okay. So that is the example, right? Okay. Now, what about another class called address? So say I have another class, right? And that's address, right? So let's say I have another class. I think I can open another. Isn't that how I do it? It doesn't respond. I open another sheet. I try to make another. Okay, just pretend there's another class. Okay, over here I just say another table. Okay, I'm wondering why it doesn't respond to me. There you go. Okay, now I have another. I'm gonna call this. I'm gonna call this addresses class. Okay, so that is a table called for addresses, and this is going to be called users class or user class, and this is going to be called address class. How about that? So I'm trying to match this to our Java. Okay, so now the address, right? The address will have, has we need to have something called ID. Okay, we always need something called ID, and we call that as a primary key, okay, to identify it. So then there's ID, okay, that's the first column. It doesn't matter which column, but I put on the first. Then you have, say, street number, right? Street number, and then you have a street name. Okay, let me actually call the property. So street number. And here is street name. Okay, so street number, street name. Actually, I would just use this way. And then you have city, and you have a state, you have a zip, correct? Okay, that's a regular address class when we write it. In other words, when we write such a class, we need to have a street number, we need to have street name, the city, state, zip. But because we are putting them in a table, so we need to identify them in a table to facilitate those different rows. We need an ID that we don't need to have in our address class, but in a table we must have it. Okay, because now all the objects in other ways in one place, so we have the way to identify. We don't have like a student one, student two, I just one, I just two. So that's really, we need an ID. So the ID will be one, say, so the street name number is say 100, and this is the main street, right? City is Selden, state is New York, 11784. Okay? So that is one object. You can already tell, right? That's one object. Now, the second object, ideally, you may want this to be two, right? So this way it keeps unique. right? Just like what we did in our 148, we have this unique ID, just increment a static integer. Remember that? Okay, so now it's a 2. Now this address is a 200, and this street, I don't know, it's called a College Road, and this is, say, I don't know, say Centeridge. How do you spell that, right? And then it's New York, 117, I don't know, I think it's 370. I vaguely remember that. So now you have a 3, you have another address number is 40. So this is university drive, I don't know. And this is called, say, Stony Brook. So this is another, and say you can say in New York, 11790. So you can see this can grow as much as you want, right? Because you can have as many rows if you want. That's the design of a database. Okay, so now we have two tables. One is this, right? So I can have some more. So another one that is a Adam, and then this is a Smith, and this is a 4. This is Joey, and then this is, I don't know, Jones. Okay, so I have these 4 names. Okay, now you also realize when we did our user class, we often has an address field for each user. We could do that, right? When we write a user class, we could have a username, password. We could also have an address, right? Address type is address, right? In other words, here, watch, we're gonna have, that's how we do it, address ID. Okay, so the ID, so now you can see John Doe lives at the address 43, see, at this location. So now all we have to do is put 3 here. That identifies John Doe lives the address ID 3. ID 3 is here. See, is this address, because that ID uniquely identifies this address. Okay, now I can go back to user. So Jane Doe, I can say also seems like a family. We put them into the same address, hopefully stay in the same address. Okay, so now we have Adam. Adam lives number 1. So that's the Selden, right? So we can put 1 there, and then Joey at 2. See, so now we have a system that can map to our Java classes. So in fact, these 2 tables are exactly what we need to put into our database. Now you can already see the similarity between the Java classes and this. Okay, now I'm going to talk about some important terminology here. Okay, the very first one is, you see the ID that uniquely identifies each row, right? Okay, so the ID has to be unique. Okay, this column is called a primary key. Just remember that, okay? That's called a primary key. So I'm going to write this here, primary key. Okay, so primary key uniquely identifies each row. Okay, now primary key could be 1 column, could be a combination of multiple columns, as long as they can uniquely identify a row. Okay, in this case, just 1 column, just the ID. Okay, now you look at this 4th column, that's address ID. You see that one? This address ID, if you look at this, these numbers are actually the primary key values from another table. See this? So this is the primary key for this table, right? For this address table, because they uniquely identify each row, right? So that's a primary key also. But going back to the user table, then this column is used to reference a row in another table. You see, this one reference a row in another table. Let me get this person in. So 3 uniquely reference a row in the address table, which is this address. Okay, and 2 reference this one reference this one. So this has a very special meaning because this is like an index. It allows you to link John Doe to an address from another table, from this table, this address. Okay, so because of this, this is very important. It deserves another name. So we call that foreign key. Okay, the foreign key is simply a primary key of another table. So by having a foreign key, you are able to combine or link 2 tables together. Is it okay? So this way, every table is simpler. Of course, you can link them, just create one big table, right? You can do that, right? So you can do that by doing something like this. You go to address, you copy this. That's 1, right? You see, that's 1. So I can copy this. Okay, I copy this and I put it into, that's 1, right? So I put into here, say here. See? So I can do that. So let me move this thing away. Okay, I'll put it into here maybe. Okay, you don't really need it, but okay, so that's 1, right? So now the John Doe and the Jane Doe, the couple, live at the address 3. So I will go to 3. So theoretically, I can do this. Copy and put over here. Okay, and put over here. You see the reputation? You see the redundancy? It's the same information. Okay, I'm taking 1, 2, 3, 4, 5 columns, just just cells, just for the same information. Okay, so in other words, you do not have to have separate tables. In fact, you could theoretically combine multiple tables into one table, like I'm doing here, right? So 2 would be here. Okay, so put into here and there. You see that? Theoretically, I can do this, but this is crazy because you can potentially, the table can grow really long. Okay, so it can be tens of columns if you grow like that, right? You can have a GPA, you can have, a phone number and school address, all the courses. Imagine that you can have all the courses you've taken, all your grades. So you can populate that in one table, but this table will be very awkward, very, very heavy, and then awkward to operate, to do search or anything. So that's why we do not want to do this, even though this is possible. We do not want to do this. Instead, we want to break them down into multiple tables. Okay, the fewer tables you have, the easier, the more efficient your database becomes. So that's something you remember. Okay, so try not build big tables. Instead, build um, more small tables, and that will make your database a lot more efficient. And we call this what we call this process normalization. Okay, it's just like when you write a class, you don't want to put everything into one, all the fields into one class. So you want to use classes to, composition. One class contains other classes, other objects, so on and so forth, right? So the same idea. So because of that, we do not want to do this, okay? We do not want to do this because potentially there's going to be repetition and the table gets very heavy. So we can delete all these stuff. So now we just have back into here. So now to summarize, for every table, we must have a primary key. The primary key can be one column, could be a combination of multiple columns, but the key is every key has to be able to uniquely identify a row. Okay, so that is the primary key. Now, a table may also contain foreign key. Foreign key is the primary key used to link to another table. Okay, so this is linked to the address table, whatever. So you can have multiple foreign keys because a student username and password could link to this is the home address, home work address, home phone, work phone, so on and so forth. So you can link to multiple. Okay, you understand that so far? Yeah. Okay. So now we see the similarity of these, and so now we're gonna do it in SQL now. Okay. Now we're gonna go back to our here, right? We already create a database, right? By doing this part. See, we already database, but database right now is empty. So our next job is to create the two tables. Good. To create the two tables. Okay, now just go to SQLite and you will see create a new table. You see this? So that's why I like this much better than the other one. Okay, so create a new table. See, that's how you create a new table. All right, so this is the template. So what you do is anything you see capitalized, those are SQL keywords. Just like Java, public class, and you know that kind of thing. Okay, static. Those are keywords. But here, anything SQL keywords are marked by capital letters, even though you don't have to do it, but that's a convention. You could use lowercase, but people usually use a capital. It's easy to read. Okay, so to create a table, you use the keyword create a table. Easy to understand, right? Then if you want, you can also have the option. That's the option. The square bracket is just either you can use it or don't use it. That means if the table does not exist, you can create it. If it exists, don't create it. Okay, in our case, of course, it doesn't exist. So all we have to do is we're going to say user. That's the name of the table, right? But because it's a table, it contains a lot of users. So we may want just put a users with a plural. So this way we know that the table contains multiple users. Make sense? Okay, because when we wrote the class is meant to create one object. That's why we use a user. But now we're going to use users, okay, as the table name. Okay, now here are the columns. You see this one called a primary key. Okay, so what we need to do is we're going to say ID. So that's the name of the primary key. That's the first column name. In other words, that's the column name. The first column name is ID. Okay, now we want to make it an integer. So just like we did with the ID, the integer keep on growing as big as you want, millions, billions if you like to. So make it integer type. That's a data type. Okay, that's like a private int ID in Java. Okay, data type integer. Also, we specify this is the primary key by using the two words primary key all in caps because they are keywords. So now by doing this, we identify the ID is the primary key. Okay. In addition, you can also add this auto increment. That's our static ID. So this way, plus plus. So every time when you create a row, a user, when you insert into the table, the ID will grow by one, will increment by one, and it's done automatically. We'll start with the number one, the next one will be two, next one will be three. So it's automatically managed, so you don't have to worry about it. So it's guaranteed to be unique. So all the thing we did in 148 was to prepare you for today. You see the similarity? So everything's matching, right? So now you see this auto increment, right? Now, first column, the second column, I'm sorry, column name, we're gonna call this user, oh, I'm sorry, that's not a keyword, username, that's our name, our variable name, right? Username, and the type, okay, type, in Java, we have string, right? But in SQL, there are all kinds of strings. The most common one is called varchar. Okay, char means character, var means variable. So it's variable length of characters. We're gonna use that for the username. So we can even provide a number, say 30 in the parentheses. What that means is maximum this username can go up to 30 characters long, maximum. Okay, why you want to put a cap here is because this way the memory management is more optimized. You know how much room to reserve for the username. If you don't put a cap on, say someone create a username with 1,000,000 words, 1,000,000 characters, and the database has to be able to deal with it. Right? By putting a cap, so the database knows to reserve this much space, up to 30 characters long. So it won't go crazy. Okay? Because 30 is reasonable probably for a username, right? Probably 10 is reasonable, but to be on the safe side, we make it 30. Okay? Now here is a not null. That means the username cannot be blank. That's a requirement. And if you say no, that means the username could be blank. Okay, not null means cannot be blank. Okay, now then we can have the second one. The third column is called a password, right? And the type, we can also just a string. So varchar and 30. So, you could say 50 or 80, whatever. Doesn't really matter. But the idea is we would like to put a cap on. Okay, all right, so now don't forget we need to have an address ID. Remember that? Remember that? So this way we can link to another table later on. Okay, so we just have fourth column address ID, right? And address ID, and that is going to be integer, same thing. That's it. Okay, so you don't need a comma because that's the last one. If you do have other columns, then you put a comma, then press Shift and Enter. It gives you another row to type. Okay, by the way, all this format, just like in Java, doesn't mean anything to SQL. Okay, it's for us to see the structure more easily, to see this many columns. So you can put them all in one line. SQL cannot care less. You got it? Okay, so it's for us. So since the enter alone is to execute this statement. Okay, so if we want to change to the next line, we have to put Shift Enter. Then it will open a new line for you to type without executing the whole thing. Understand? Okay, in this case, I think we are good, right? So we can just get rid of the last comma because that's the last line. And then you do have a parentheses to close it. And usually you put a semicolon, but it's not required because we're doing one statement, so it's not required. All right, so we're ready to execute it. Okay, all we have to do is hit Enter key, just double check, we create a table. If the table does not exist, the table name is called users, and it's going to have 4 columns. The first column is ID, which is the primary key, and its integer type is the automatic increment, and the username is a varchar type, cannot be null. Password is also varchar, could be null. Okay, and there's a foreign key, which is the address ID, that's integer type. All right, so there you go. Hit enter, and there's no complaints. You see, so that means the table is created, but the table is empty though. There's no rows yet. You just have a column type, column names. Okay, we have the structure. We don't have the no actual data. Got it? Yes. So what's good? All right. Now we're gonna create the second table. Remember these addresses, right? So we're gonna just go back to the same place. We're gonna create addresses. Create a table if not exist. So we're gonna call this. Oh, sorry, hit the wrong key. Addresses. Okay, so that's addresses table. All right. Then ID is we're gonna call this address ID. How about that? So this way easy to remember. Easy address ID. Okay, and then is integer primary key also auto increment, and then here should be street number. Okay, watch out 30, fine. No, doesn't matter. So it's up to you, however you want to define. He said, I would allow you to create an address without street number. That's fine. Leave it blank. That's fine if you do want to do that. And then street name. Okay, and that is varchar 2. And so let me just put it in nicely. And that's 30. And could be blank. And then I want to do a city. Okay, that is varchar. And city name, say 30, comma. Okay, now I want to, I'm sorry, I need to enter a new line. Oh, not here, over there, right? So shift enter, open a new line. Okay, so I have state, and state is what? We're gonna say varchar, and state is 2. So NY, CT, whatever, right? Comma, and then shift enter zip. Okay, zip and varchar. Then you put a 5. No, sometimes people put a there's a exchange. What they call this after zip? There's a 4 digits. There's a name for that. If you want forgetting that. Well, anyway, so you know what I mean, right? So it's a 5 plus 4 plus 1. There's a dash in between. So we have 10. Okay, so that's the maximum zip you can put in. Okay, so that's it. So we don't need that comma or semicolon, nothing. Then we can just execute this. Now the second table will be created. Good. All right, so I'm going to hit enter. Now second table is created. So now I have 2 tables. Both tables are empty. Good. So now I need to put stuff into the tables, right? And the first one, let me open this. The first one is John Doe, address is 3. Remember that? Okay, so we can do that. So go back to here. All right, so that's how you're going to insert data into the table. Here, go to SQLite, and you see insert, where's insert? Add a new column, create a job, creating, trading, inquiry, insert the new row into a table. You see this? Boom, there you go. So now keyword insert into all caps. So you know that's a keyword. Now followed by the table name. Table name is users. See that? Okay, followed by the column names. The first column is automatically increment, that's the ID, so we don't have to worry about it. It starts with the 1 by default, keep on going up. Okay, so we can just have to put down user name, right? Second one is password, I think. And the third one is address ID, if I remember correctly. Okay, so address ID. And now, so here are the values. See the keyboard values? So we have values. So we're going to separate it by comma. The first one is username. So we're going to say John. So make sure you put it because it's a varchar. So put a double quotes. Okay, comma. Say the password is Doe, comma, and then you're gonna have ID. So John Doe lives where? I forgot. Number 3, right? You see, John Doe lives 3. So we're gonna put a 3 there. Although I don't have 3 yet, it doesn't prevent me from entering it, right? So I'm gonna have put a 3. So address ID 3 is gonna be where John doesn't live. Okay, so put a semicolon and hit enter. Now that it went in. Okay, now we can go back and add a few more, and then we're gonna add this time is Jane Doe. Okay, and she lives at address 3 as well. Okay, so we're going to hit enter. So Jane Doe went in. Okay, now you may wonder, did it really happen, right? So we can take a look at it. To take a look at it, we can use select. Okay, that's a query now. That's called a query. Select everything, every row. Star means every row, all rows. Okay, select everything from, okay, users, not dot users. See, I'm going to select everything from the users table. Okay, now I hit enter. Yay, you see this? See the 2 rows? So the data actually went in, right? Not only went in, but also in the right column. See the ID automatically increment from 1 to 2. John Doe, Jane Doe, all live at address ID of 3. Yes, good. Okay, let's add a couple more. Okay, so let's add a couple more. Let's go back in here. Let's see what I have Adam Smith and Joey Jones, right? So let me go back, go into here. I have Adam Smith, and this person lives at address 1, address 1. I'm sorry. So he lives at address 1, and there you go. You went in, right? So you went in. Let's see if it actually went in. Hit enter. Yeah, there you go. Adam Smith went in as well. See, I did another select. Okay, so now just add one more. I think it's Joey Jones. And then the address is 2. So the ID is 3, 2, I'm sorry. Then hit enter. So that's added. Now I'm going to see this. Now all 4 people went into the table. Okay, so far so good, right? So we don't have to add more because, you know, this is the same thing. So now we're going to put the data into the second table. Okay, so putting the second table, we just do insert into addresses. Okay, that's addresses table. Make sure I spelled it right. Addresses. The first one is called street number. Number. Second one is street name. Name is lowercase street. And then the one after that is city and state and then zip, right? And then the values. The first one is say, I don't remember, 100. And this is a Main Street, I think is. And then this is city is Southern. Make sure you use double quotes. Okay. And then you have New York and then 11784, I believe. Okay, so we try to put this in there. No, 11884. 11784. Oh.
Double quotations. New York.
Here. My bad. So the New York. All right, so let's try it again. It went in. Okay, it went in. So we can do the same for other people. And then I don't remember the addresses now. They are 200 College Road, 40 University Drive. Okay. 200. Where? There you go. So 200 College Road, and that is Center Ridge, I think. Center Ridge, New York, 11730, I think. So let's enter that. So that went in. Let's just see if it worked, right? So let's try look up the addresses table. Oh, I spelled it wrong here. This is table, right? Just see what's inside. I should have two addresses. That's there. Oh, cool. Okay, now we can add the third one. I think it's a 40. 40 University, what is it? Drive, I think it's University Drive. This is in where? Stony Brook, isn't it? Did I say Stony Brook? I forgot what I said. Okay, say pretend it's Stony Brook. 790. I think it's Stony Brook. Yeah, it's Stony Brook. Okay, good. So now we are there and hit enter. Now it all went in, and now we're gonna see all three rows in the table. There you go. Okay, so so we have two tables, then populate them with the data in this particular way, and then we also were able to select for things, right? Okay, now I'm gonna do something else. I'm gonna select select password field. Remember the password thing? Remember the password from users table. So from the users table, I want to see the password column. Okay, so hit enter, and then I just show the password. You see how they do search? We put so much effort when we did data structures to do search. Now see how simple this is, right? And not only can do that, and then you can also do things like let me see, you can do things like order by. Okay, so order by, okay, order by say by the column, which column? By username, ascending. See, I want to sort the output in the ascending order, sorted by username. Remember, the username is the first column, the second column after the ID. So hit enter. You see, all the passwords come out, and they're all ordered by the username ascending order. Okay, if you are not sure about this, now you can just do this. I can look at everybody, every piece of data, sorting by username ascending order, and there you go. You see, that's the username ascending. You see this ascending? So that's what I'm telling you. The database is so powerful. All the code we wrote before now is one statement, right? So you realize life gets easier, no? Life gets easier and easier as we learn more. The hardest course is 148 because we have to do everything by hand. Now everything is all the problems already solved. People made it a little easier. So and then we can also do a descending order. Descending order. You see, descending order. Okay, so now that's descending John, Joey, Jane, Adam. Okay, and we can do something like this. Select everything from user. Then I can say something like where that's called a where clause, where username like anything start with a percentage J and percentage. Okay, that means I want something that contains J in the username. Contains J. So that means Adam should not show up, will not return. Okay, now hit enter. You see, there's no Adam. You only have John and Jane and Joey. So you can even say O, J, O. So then in this case, it will be John and Joey. Okay, see, hit enter, John and Joey. And it does it really fast. So it almost make you feel like we wasted the whole semester. We could have just doing this instead of doing the last week. We can start this in the first week. Right? Do you feel that way? You feel like you were cheated and misled, and we shouldn't have do all the things we did. Okay, now what if I want to combine the two tables? Okay, I want to look at everything. I want the username, passwords, street number, street name, and then whatever, combine data from two tables, right? So that's how we do it. So select everything. Instead of everything, I can say, I want to look at the username, password. I want to see where the person lives. Only care about the city. But if you want other things, you can just list there. If you want to state, that's fine. So username, comma, password, comma, city, comma, state, you don't need a comma. Then you're going to say from the users table. But you do know city, state are not in the users table, right? Because that's in the address table. Yes? Okay, so here's what you're going to do. Okay, so you're going to do something called inner, that's a keyword. See that? All cap. Join. So you're going to join another table, right? Because that table is called addresses. That's a table. You join that table. Okay. On. On is actually a keyword, but people is a condition. So people do use lowercase, but you can use capital. So on what? You want the address table. In that table, the address ID equals your users table dot address ID. Okay, so you're going to join your users table with the address table. Only display rows that will match this condition. What a condition is the addresses table's address ID equals the users table's address ID. Remember there's a foreign key on users table? Okay, so that is match. So now we hit enter. You see? You find everybody whose username, whose password from one table plus city and state from another table. The link is what? The link is the ID. That is the foreign key on the user table, primary key on the address table. And to link them is called inner join. That's the keywords. Inner join. Isn't that wonderful? Okay, so you can look at everything up if you want to, right? I just list the certain state, but it could be anything. Okay, now if you want, you can also do things like delete. Okay, so you can delete. I try not to delete yet, or I can insert something and delete. So I'm going to insert the street number. So this time is make 0. Hold on. 0, that is the user name, right? I mean, this is the address. So I'm insert a new address in there. The person live the address, street number is 0. That's one I want to delete it. Okay, pretend I made a mistake. So this is a so University Drive, Stony Brook, New York. So this is one I'm gonna add it. Then I'm gonna delete it. Okay, so I'm gonna add it. So now that's added. Okay, that's added. Now it's added. How do I know? I can show it. Okay, so go back in here. So select everything from the address table. Hit enter. I do have this one. You see the fourth row. I added. Okay, the address number is 0, and everything's the same as the third address. So I want to delete this now, right? Because this is not what I want. So I just say delete. See removal when we wrote all the Java code for remove and delete by ID. Now we can say delete, right? Delete what? Delete. We could say from. Okay, sorry, from the addresses table where, that's a keyword, where what? Where the address ID equals 4. See, that's okay. Or you can say where address, street number is 0. But everybody who has a street address of 0 will be deleted, because that matches, right? Then you're going to say where street number is 0 and street name is University Drive and city equals Stony Brook. Then you can do that. You can combine them. Okay, but I know ID 4 is the one I want to delete. So now that should be gone, right? So now if I do this again, you see, that fourth one should be gone. See, only 3 left. Very cool. Okay, so I think that's all we need for now for us to understand SQL. Okay, now this is universally the same across the board. So now we're going to move to the second part of this lecture, which is Java. Okay, how to do all this using Java. Okay, so let's go start our Eclipse. Okay, and I'm going to do something like this. Let me see. What I'm gonna do is the time 40, 35, 40. Okay. Maybe I will actually type out the code so you will understand better, maybe. Okay.
Professor,
Yeah,
quick question from that.
go ahead.
Um, when you joined the user table with the address table, did the user table I guess, is gone now or still there by itself, the user table?
Of
When you
course
join?
it's there.
It's
It's
just
there.
by, is there
Yeah.
still?
Of course, of course. Otherwise, all these other things like username, password came out. You see this?
Yeah, but after you join it, did the user table just, I
No,
guess,
they're still separate. Just momentarily, you
oh,
pull data from 2 tables. You're
well,
not you're not creating a third table.
oh, okay.
Okay, you're not physically joining them.
Okay, got it.
All right. Okay, so um, so I'm debating how I'm going to show you. I'm sure if I type the code, then you will follow better than reading the code I wrote. Okay, so maybe I will do this then. Okay, I will type the code. Um, at least get the fundamental thing down for you. Okay, so I'm going to open up Eclipse. Okay, I'm gonna start from scratch. Okay, so I'm gonna show you my Eclipse here, and you can see, right? And I'm going to open a new project, like starting from scratch for you. Okay, I'm gonna call this database tutorial, maybe? I don't know. Tutorial, fine. So I have this project, and then I'm going to say finish. Okay, so this is the same. All right, so nothing unusual so far. And to make this work, I need to have that JDBC jar file. Remember that? As I showed you how to download it, right? So I have it here from before. Okay, so this is the file. I downloaded 3.32. Remember that? So I'm going to copy this instead of go download it again because we already have it. So I'm going to put it into my project folder. Oh, that's not what I want. Sorry. What did I do? Control Z. No, you won't let me. Let me just delete it. That's not what I want. I want to put it into put in the database. Okay, I may have to go there to actually physically copy. All right, so go to my documents, go to my 248, go to the project folder, SQLite, and here is the thing I needed. You see this? The downloaded file last time. It's called SQLite -jdbc, then with the number, then .jar. So I'm going to copy that. I'm going to put it into the new project. The new project. Okay, just spam. Forgot to turn it off. Okay, sorry. And then I'm going to put it into the new project, database tutorial. Okay, so I'm going to put it into here. Okay, so this way I can add it to my project. Okay, and okay, so I have this, right? And now I'm going to go into this and then right-click on this to actually add that jar file to the project. I just physically copied, but now I have to make sure the project recognize it, okay? So right-click on the project, you go to build path, go to configure build path. Okay, now you go to the libraries and the class path, then add external jar. You see this? Add external jar. All right, then I go find this. This is the old one, so I'm going back to my new one. That is database tutorial. There you go. That's the one I want to link. So open, see, this got added. Okay, so now apply and close. So I have that. Okay, so this is under reference libraries. See this? It's actually officially recognized now. And the reference libraries. Okay, so now I'm going to write our package. So I'm going to say P1, and then I'm going to write a class is a utility class. So I'm going to call I just say connection utilities, or connection util. Make it shorter. Util. Okay, so that is this. Okay, now all I needed to do here is just have a static method, public static, to make the connection to the database. Right now, I don't have any database, remember? The database is on my hard drive under the SQL manager, right? SQLite manager is not in my project yet. Okay, so one way to get it is go back to my this one. Remember I created this database, right? Remember that? Okay, now I need to download it. Right now it's in the memory. It's not a file yet. So I need to download it and then copy the file, which is database, to my project. Okay, so right now I just download it, go to manage. You see, download selected database. Okay, I don't even remember what's the name of the database. We didn't give a name, right? We did. We did user. Do you remember what we said? So now we did I say download? Download selected database. Oh, because user db.sqlite. There you go. User db.sqlite. Okay. So go to manage, go to download selected database. So it downloaded. So I just need to go back to my file. I don't know where I downloaded. Hold on. I have to find it where I downloaded. It's downloaded into where? Download? You didn't tell me. I think it should have told me 2012. No, it's not in here. It's not in here. Where did I download it? Let me see where I downloaded it. I have to go to my browser first and see where is the download folder. Go to settings and look for my downloads. Downloads.
A shortcut to downloads is also Control J.
Downloads here. Okay, so let me see. Chambi downloads should be there. Oh, okay. It just went straight to Chambi downloads. So it went there. Chambi downloads. That's OneDrive. That is downloads. Where's my download? I think it should be here, but it's not. No, that's the one I downloaded before. So 12. Did I miss it? No. So hold on. Let me see.
You
Let
run
me
the command
maybe I
on
didn't
the
download it.
manager?
What?
Did you run the command? Did you press enter and then?
That's the one I need. So I don't need this. So actually, I got confused. So you have to actually do download. Now it's there. My bad. Okay. So I forgot to do that. I thought it was just would do it automatically. All right. So this is going to unknown name.sqlite. And I'm going to go to this folder and I'm going to change this name. I'm going to copy this name. I'm going to copy this, cut this. I don't need this anymore. And put it into my project. Now, put in my project, I would like to put into a folder, okay? So go to new folder. I'm going to call this data folder. So data folder, there you go. Under data folder, I want to create a subfolder. And I'm going to call that DB, okay? All right. So now I'm going to put inside the DB. So that is the database. And I don't like the name, so I'm going to rename it, refactor it. I'm going to call this name userdb. That's SQLite, I think I called it. Userdb.SQLite. All right. So finally, we got a database into my project. Okay, good. All right. Now, okay, fine. So here is what you do, right? So you're gonna say public static, and this static method is gonna return a connection, the SQL connection to the database. Okay, and then we're gonna call this method get connection or create a connection, and then over here you're gonna use this thing called like this. So I'm going to import a connection and just make sure you put the one that java.sql because there's many of those. Just pick the java.sql one, okay? You got it? So java.sql, so that's connected. So get a connection, then we're going to have a return. So we're going to have a return the connection eventually. But before we do that, I need to do one thing. It's called a class class dot for name. Okay, so what does that mean? That is org dot, just remember you have to put the same thing, SQLite dot jdbc. Okay, what does this do? This program checks, this statement checks, see if you downloaded or recognize that the jar file or not. So if you didn't do this, this will give you an error message. The class not found. See that class we did? So this should pass it, okay? So in case, just to be on the safe side, we do a try catch. So if we didn't do it, of course, we get an error message, right? So that is that. So we're going to now get a, we try that, and then we're going to do this. So we're going to say return. Now we're going to return the connection. The connection is called driver manager dot get connection. It's a static method. And here you're going to say jdbc dot SQLite dot the location of that database we downloaded. We copied over. So that's under data folder, db folder, then user db dot SQLite. Okay, so that is the one command you need, one statement you need to get a connection to the database. That's how simple it is. Okay, so let me import that java.sql, see, driver manager. Okay, and then we're going to add a catch clause. All right. Okay, that's it. So whenever we need to connect to the database, we use this to connect. Very simple. It's just one method. The key of this method is really just this line. If you don't care about this, if you know this, you downloaded and installed the library, all you need is to get a connection like this. That's one statement you need to get a connection. But we play it safe. We check, see if the jar file is downloaded, installed correctly, and we have exception handling. So that's that's the one. Now, second method I want is static Boolean, and this one is called a close connection. Okay, that's connection. So if you're giving me a connection, I'm gonna close this. Okay, how to close? So I would say if connect, okay, connection is not equals null. That means there is a connection. If the connection you pass, Boolean connection, if there is a, then we say, so connect dot connect. So we connect dot close. Okay, we close the connection, and then we say return true. That means we truly closed it. Then we do a try catch. Okay, so let me put the return true there. Cut this. Okay, so we return true, and bring up this, and then we're gonna say otherwise return false. Okay, so there's another one at oh, that's if else if there's no condition with else, my bad, else we're going to do return false. Else, hold on. Try there, my bad. So I'm gonna delete this. And that's if, right? So else return false. That means we're not closing it. And then finally return false. So that's formatted. So that's our close connection method. So with these two methods, we can open a connection to a database. When we're done, we close it. So every time you want to insert something, you open it and insert. Until you're done insertion, you will close it. And then every time you retrieve anything, you search or retrieve or delete, whatever, you have to open a connection, connect to the database, do the job. When you're done, close it. Okay, so we need those two methods. All right, so now with those two methods, we can now do our demo. Okay, so by the way, let me make another point here. The point is, since we already have this database, what we created earlier, remember, by using the SQLite Manager, we created this, we download it, right? If we don't, just by having this, you're going to automatically create an empty database. In other words, you do not need a SQLite Manager to create a database. Just by putting this in, if there's no database, it will create one for you. But if there's one, it's not going to create one. Okay, since we already have one, so so we're going to use the existing one. Okay. So far so good. So far so good. Anything? Any questions? No questions. All right, no questions. Then we're going to actually do our demo. Okay, the demo. What's going on here? We're going to do a demo. New class. I'm going to call this main class demo. Main demo. And there you go. Okay, so we're going to say we're going to say connection. We declare a variable connection equals null. That's initially is null. There's no connection. Okay, I'm going to import a connection. Java SQL, and then we're going to say we're going to get a connection now, and equals, right, equals connection util dot get connection. Okay. So now we get a connection. We're using that get a connection method we just wrote, right? So we have a connection. Once we have a connection, then you have to do this. You have to say statement. That's the prepare you to do statement. Okay, we're going to call this statement equals statement equals connection connection dot create statement. So in other words, we create an object called a statement object. Okay, so I'm going to import that. Okay, out of this connection. Okay, and I'm going to add this try catch. Okay, so there you go. we have the connection statement. Once we have a statement, we can also do something like this. We can say statement. This is not required, but said query timeout, and we put a 30. So what that means, when you try to do query, if the database does not respond, okay, within 30 seconds, then you will quit. You don't want to sit there waiting forever, right? Because the database could be somewhere else, could be not there. So it will just give you a timeout, which is not required, but it's good to have. Okay. Now, if you want to create a table, you can say statement, then dot, this is the keyword, execute update. Execute update. Then here is the double quotes where you're going to put down your query, the SQL statement. Okay, so remember we we're able to create a table, right? So remember that create a table. We used that before. We do not have to do this, but I can show you this is what we do. The same statement, create a table, and we call this table students. Okay, so I'm creating a new table, and then the student. So student. Okay, now the student will have student, then parentheses student ID. That's the first column. So that's a student ID. That's the first column. Make it a small lowercase student ID, and then space, and then you can say integer. Okay, and then you could say primary key, and then you could say auto complete or auto increment. So that's the first column, comma. Okay, that's the first column. And you can put it on two different ways. You can put it look like this. See, that's the first column, and hit enter. Now there's a second column. Second column will be we would say first name. Okay, that would be varchar 50. Okay, comma, and then last name. I'm just showing you you can do this even though we don't need it. 50, comma. So we just have one simple table, then that's fine. Just put in double quote to surround it, then you close that. So that's how you execute a SQL statement to create a table. Now we're going to have a new table in that database. Which database? That the database is called user db.sqlite. This is in addition to the two existing tables. We're creating a new table, which we don't really need. Okay, so and then if you do want to put other things in there, you could. So you could say statement dot execute update. Okay, so then you can say insert. Remember insert? Okay, into which table? We decide which table you want to do. So you want to put a table, say, what we had users, right? So we have the users. That's the table. Okay, users, and then we can have the columns. The first column I think is called a username. Username. Second column is a password. Third column is address ID, I believe. Okay, address ID. So these are the three. Let me just make sure. So we have. Let's go back. Just look at it. Okay. Select everything. Select everything from users. There you go. So yeah, address ID, username, password, address ID. Okay, so going back to here, so we have user address ID, and then we put this, and then we put it down values. So we're gonna put on a separate line maybe. Okay, values. Then in the values, you put it down the three values. Username came up with a name, say Julie. Okay, and then put a last name. So last name say is say Jones. Okay, so Jones. And then you have the address ID. So I'll say 2. So that has the 2. And then 2 is values, Julie, ID. 2 is an integer, right? And then we're going to have values. So that should be okay. So now I have a double quote, and then I have hold on. Values. Oh, it doesn't like to be double quote because I forgot. The Java double quote has a special meaning for string. So for this SQL string, so you have to put a single quote. My bad. Single quote. Because Java has its own meaning for double quote. And then once you have that, you have this semicolon. There you go. So now you added a new row into the users table. Okay, so we added Julie to this users table. In addition to the 4 rows we had before. Okay, got it? All right, so we added that. Now, once we added that, we could retrieve things, right? We're going to retrieve. So how to retrieve? We can use this called execute query. So this is how I'm going to do. I'm going to separate this a little bit, right? Result set, that's a class, and we're going to call the result set equals statement dot execute query. This is the one that says query. Others called execute update to insert, delete, or create. That's called execute update. But to do query, to the select, you have to do execute query. So then you put down double quote. That's a string, right? Select what? You're going to select everything from the table called users. Okay, so we're going to try to get everything from the users. Okay, so we're going to say semicolon. So I mean import result set. So that's java.sql. So now I have a result set. So basically, this result set is a set that shows all the returns, all the different rows that match the criteria. In this case, it's everything from the users. So all 5 rows. Okay, so now we have to split them because the 5 rows, there's 5. We have to split them one at a time, right? So we have to say while. That's like reading a text file, all as result set dot next. So as long as it has the next, because I don't know how many lines, how many rows there, right? So I just say as long as it has the next, what we're going to do is we're going to say sys out. Oops, sys out. So I'm going to put on 1 line. I'm going to say print. I'm going to say something like and first. I'm going to say user name colon plus, and then we're going to say result set dot get string. See, I'm getting the data now. Get a string, and then in the parentheses you put the column name. Which column? User name. Okay, so that username is the column name, so we're going to put it down here. No, it's a string, it's a method. So I'm sorry. So it's not a SQL statement, my bad. So now you are getting the username part from that column for that first row. For the first row. Okay, so I'm going to add the other row, other fields as well, other columns as well. So the second one is the password, user password, and we'll get the password. So I don't want to do dash n. I want to do a dash t. Okay, a tab. Okay, so I'm going to copy this and paste over there. So the third one is the address ID, right? So I'm not going to do the because when I did this, I didn't do the inner join. Remember? So I don't really have the city and the state and everything yet. I'm not combining yet. So I just dealing with one table right now. If I did inner join, then the address table, then I could join them, but I didn't. So, or I can, if I have time, I'll show you how to do that. You probably can figure that out. So I put the print line, get a password. This time is go to address ID. That's the column name, address ID, I believe. Okay, so we get all this. Once we're done with that, then we are, that's it. So we catch. Okay, so let's run it, right? Let's run it. Hopefully we'll get the full names and plus Judy Jones, 5 total, right? So let me run the program, and nope. So the driver found for jar DB SQLite. 16 is okay. Driver manager. Interesting. I don't think there's anything. It's all set. When I'm done, I'm just gonna close it. So let me just add the statement, but I don't think that's the reason. Finally, and let's close it. It's called connection util dot close connection, right? And the connection is called CONN. Okay, so that's close the connection. The reference library is there. DB user DB SQLite is there. Just make sure. JDBC. So SQLite JDBC. Did I mistype anything? JDBC, that's correct. JDBC column. I did. So it's a column, not a period. Column and then SQLite column. My bad. Okay, SQL, then data, then this is all correct now. You couldn't find it because the path wasn't right. Okay, now, so JDBC column, SQLite column, data, then that's the path where the database is located. Is in the data folder, DB folder, subfolder, user DB.SQLite. All right, so let me run again. It's a different type though. Missing database, incomplete input. He found it this time. Okay, 18 is not a problem. Create a table, create a table, student, then. So let me, I don't need to create a table. Let me just get rid of this for now. Maybe I type it wrong somewhere. So I insert this, let me see. Yeah, so there's a typo there. I need to figure that out. But over here, you need to find out, you see, there are 4 entries. Okay, so Julie, 5 entries, see, Julie, Johns, Joey, John, Adam, Smith, Jane, Doe, John, Doe. Address ID is all correct. So it worked. You notice it? Yeah, it worked. Okay, we retrieve the data. But if you just do a login program, like then it's not that. You just get 1. You retrieve by 1 by the username. Because the username has to be unique. You actually can make that ID or a unique thing. All right, so let me see what are this doesn't look great because the way So Judy is long. We took 2 tabs, so maybe you have another tab. And this is okay. This is another tab. I'll make it better. Judy is. Oh, when I run second time, you know what happened? Judy gets added again because every time I run it, Judy gets added. So this time you get 2 Judys, which makes sense, right? Because once you add it, it stays in there. So I really should stop adding, right? Should stop adding. So now I just display what's inside there. There's 2, see? Well, anyway, so it doesn't look great just because of format, but you know how to get it. I think that's good enough. And then I have the code under here, under the JDBC SQLite. Under there, I have 3 programs. One's simple like this, and then this is the one that's the login with a scene builder. Okay, so that's the scene builder one. You see this? So whenever a connection is made, okay, so it returns true, then it's connected. It shows connected. Then you will connect to the database, DB, student DB1. So that's where you're going to say Adam Smith. Okay, so that is logging successfully. And if you have anything else, we'll log in failure. So that's how you query. So that's the application of this. And we don't have time to go over this, and with the background we already have, you should be able to figure this out. Okay, so overall, over here, you can insert, create a table. That's the one we went wrong. Statement, execute a table, create a table, students. Then you have column, student ID. I think that's what's wrong. Student ID. Student ID, integer, primary key, or increment, not, no. Okay, so this can be not null. Student ID, then comma I missed. No wonder. Comma I missed. Then first name, comma, last name, then you don't need comma. Just no comma here, then semicolon. So let me enable this. Hopefully this will go through. First name, voucher, 50.
Comma has to be outside the quotations
Ah,
on the next line.
right. So that's okay. So now let's run this, see if we will create it. We're not going to, yeah, we just query the same thing. We're not going to add the new stuff into the table. So, no. Not, no. Ah, there's no comma here. There's actual comma there. So now let's try. Nope. Incomplete input. So create a table student ID, integer, primary key, auto increment, not null, comma, correct. Then first name, varchar 50, comma, last name, varchar 50. I don't see any problem. Create table, student. I don't see any problem. Student ID, integer, primary key, auto increment, no, comma.
What about the open bracket, open parenthesis I should say, at the first line, the student
Here,
ID? Second.
here. You need that, then you have to close it. You need that. Did I close the property? So this one close here. Then you need another one. So you need a
No, you need another one inside the quotes.
inside the quote.
Yeah. Then that should be good. Should be.
Yeah. So this one matches this one. This one matches that one.
Mhm.
All right, let's try. Yay! So now the new table is created. Okay, so you can do the same thing. You can add stuff to it. Now we're gonna add stuff into there and say insert into students this time. Okay, so we're gonna put a student. Okay, and then the first column is first name. First name. And second column is last name. Okay, so last name. Huh. And then I don't have address ID. Let's get rid of that. And then the values. This time use first name is Julie, last name is Jones, and we don't need that. We don't need that. And the value is this, and then that should be it. Jones value, and then this quote. Close that. That should be okay. So now I'm going to enable this. Okay, enable this. And then we're going to insert this into that new table students. Okay, not into the other one. So this one's still going to show up. So insert into students, first name, last name. Missing database table students already exist. It's already there. So we're gonna say insert into create table if not exist. If not exist. Because it already exists. So we don't have to create a new one, in other words. So the table is already created, in other words. Now we can just insert. Because when we run this again, we're creating a table again. Okay, the table is already created. So we just insert this. That should all work. Yeah. So you added this. Now we're going to get everything from the student table, right? We can get this is called the first name. And we get that. That's going to be the first name column. First name column. And the second one is called the last name. So last name. And this is a column is called last name column. Okay, so we don't need this. It's because there's only two columns, right? Now we can run it, see what happens. There's only one Julie. Oh, two went in. Well, first time went in when we try, and when run this again, the second time went in. So that why the two. When we run again, the three Julies. Because every time we run it, we add a Julie into the table. Got it? Okay, so if you want to say insert, select where from students, then you can say where, okay, what I call this ID, student ID, right? I use a lowercase, okay. Student ID equals what? 1. So I get the first Julie. Okay, so I should have returned only 1 because I only want the one with ID equal 1, even though there are 3 Julies in there. See, I only get the first one. Okay, if I want to get the second Julie, just do 2, and that's still the Julie. All right, so now if I want to add another student this time, I will add disabled. Where did I say disabled? Create, exit, update, insert student. So I'm gonna, I add a few already. So I'm going to add this to John. So John add in. So I'm going to say, once you add it in, I'm going to find where username, first name equals John. Okay. So we only want to return whoever whose first name is John. Okay. So hopefully we get Jones. Yes. Okay. All the things we did before now came back. Hopefully. You like it? It's cool. It's really cool. It's very powerful. Right? So if you want to take a look at this, I have another table to show you. Not this one. So this is the business type of a table. Not this one. Here, the tutorial. And I want to show you a sample database. Okay, so that's the business application. Look at this. So you have a media type, and you have a journal, you have a playlist, you have a playlist track, there's albums, tracks, artists, see, invoices, invoice items, customers, employees, all in separate tables. They're all linked by this brown thing that's called primary key. Okay, so for example, this is the primary key, and the album ID, that's the foreign key referring to the album's ID. Right? So all this data gets linked in such a way. That's a typical business database. You can imagine how much stuff is there. Now imagine do this using your data structures, embedding all the search methods and update methods, delete methods, and all that. Right? You don't want to do that. Instead, all you just need to do is create a few tables and create a database, and then you can use existing queries statements to do it. Right? Life gets easier now. So all the things we did for nothing, nobody's going to use that. But nevertheless, all those interview questions are about that. That's the real foundation of computer science. Now, imagine you take out data structure course. You have no understanding of data structures. You have no understanding how this thing will ever work. Because all these tables behind it is data structures, maps and trees and stuff like that. Linked list, right? So that's the foundation. Without that piece, you will never understand how it's possible to build a database. But in reality, we don't need that. We go higher level abstraction. We go to tables. Remember abstraction? Most important concept in computer science, right? So I think we can now put a closure onto our study at the Suffolk. Don't you think? Don't you think like you can manage a lot of data? Yes? Easily with a database like this? Don't you think? So I strongly encourage you to do this for your final project, for this one, the final exam. Strongly recommend you do that. That will be a chance, to practice this, right? Then next week, when we meet again, we're going to talk about how to get the data, the humongous amount of data. Okay, turns out there's a parallel world, parallel universe that we don't see. People don't normally, they're not aware there's another universe out there that has all the data make up the world. We just have to know where to look. So next class, I'm going to show you where to find all the data. With that piece, then you're totally done, totally finished. You know how to get the data, you know how to share data, and you know how to use the data, put it in the database, and how to build a GUI. That's everything you need to know about building applications, right? So when you go take another course, maybe just another language, right? But like JavaScript or whatever, just another language. So no big deal. Everything you need to know is here. So we may or may not next Monday, we're gonna talk about JSON. Then if we can finish, that'll be great. Then the final day will be next Wednesday. We're gonna talk about a multi-threading. Okay, one lecture on multi-threading, one lecture on JSON and on data sharing on the internet. Okay, so I'm sorry it took me so long, but I thought it's good lecture because that shows you everything we need to know, right? Do you appreciate it? Yeah, it's nice. It's really nice. Right, give you all the power. All right, I have the examples if you look at, and I show you the this is the website, and you can see this thing about Java. So it has all the detailed explanations, like connecting to a database, creating a new database, creating a new table using JDBC, inserting data into a table, querying data from a table with or without parameters, updating existing data, deleting data from a table, managing transaction, writing and reading SQLite blob. Blob is like a big string that contains like a picture or a song. I know. So anyway, so so that's it. I see you Monday. Don't forget about the project. Do that for your final project, for your final exam. Okay? All right. I see you Monday. Have a good weekend. Stay warm. Adios. Bye. Adios.